Hello, in this lecture we'll answer two questions. In the first question, we find out the area of this square ABCD. In the second question, we'll find out the side of this angle theta, that is in triangle DOE. We start with the first question. In the drawing, we have square ABCD, line segment AP equals to 5 units, line segment BP equals to 3 units, and line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we'll do a construction. We'll extend side DC of square ABCD by a straight line. And from point P, we draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended DC as N. In the next step, we will do another construction from point B. We will draw perpendicular on PN. Again, from point B, we will draw perpendicular on PN. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as N. In the next step, we will define side BM as A. Here, BM equals to A according to our definition. We define side PM as B. PM equals to B units in its length according to our definition. And we will implement the Pythagoras theorem on the green right triangle PBM. According to the Pythagoras theorem, the green right triangle PBM, here by PT is abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse of the right triangle PBM is PB. Therefore, the square of the hypotenuse is PB squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM square. Repeat again, in the right grand triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. The hypotenuse PB equals to 3 units according to what is given as the equation, therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM is B, therefore PM square is B squared plus BM square. BM is equal to A according to our definition, therefore BM square will be equal to A square. So, in conclusion, we found out that according to equation number 1, A square plus B square equals to 9. We know that all the angles inside the square are right angles. So here we have 4 right angles in square ABCD. And DC is one side of square ABCD, therefore it is absolutely a straight line. Then we extended the straight line DC by straight line, and this way we got line segment DN. When you extend a straight line by a straight line, the result must be a straight line. So the result of the extension of the straight line DC by a straight line is DN. Therefore DN must be a straight line. So I write it down. DN is a straight line. DN is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees according to rule number 3. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of DC at point C? We have this angle that is equal to 90 degrees plus this missing angle. In total, those two angles must be equal to 180 degrees. So this angle, the missing angle, must be equal also to 90 degrees in order to complete the sum of the angles on the upper side of DN at point C to 180 degrees. This angle must be equal also to 90 degrees. Okay, so inside quadrangle BMCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Okay. So we found out that inside quadrangle BMCN we have 4 right angles. We will focus on the lower side of segment line AM at point B. This angle equals to 90 degrees. This angle, it is also equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. That is to say, angle ABM equals to 180 degrees. I write it down. Angle ABM equals to 180 degrees, and any angle that is equal to 180 degrees, it must be a straight line. Therefore, angle ABM is a straight line. Angle ABM is a straight line. ABM is a straight line. So if triangle ABM is a straight line, it means that line segment ABM is a straight line, and if line segment ABM is a straight line, it means that line segment AM is also a straight line. So I can write down that line segment AM is a straight line. Okay. And if line segment AM is a straight line, it means that shape APM, this shape is a right triangle. Therefore, we implement the Pythagoras theorem on the right green triangle, triangle APM. So in the right green triangle, triangle APM, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle APM is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PM squared plus AM squared. Here we will define the side length of square ABCD as x. Therefore, all of the sides of square ABCD will be equal to x units in their lengths. I repeat again, according to the Pythagoras theorem, in the right green triangle, triangle APM, we get that AP square equals to PM square plus AM square. AP equals to 5 units according to what is given as the question, therefore AP square is 5 square, that is 25. And it must be equal to PM square, PM is B, therefore PM square is B square plus AM square. AM equals to A plus X. Therefore AM square is A plus X square. So in conclusion, we found out that according to equation number 2, 25 equals to B squared plus A plus X squared. Here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, (25) equals to B squared plus A plus X squared equals to A squared plus X squared plus 2AX. In equation number 2 we have A squared plus B squared, and according to equation number 1, this equation we have already found out that A squared plus B squared equals to 9, therefore we substitute A squared plus B squared in this equation number 2 by 9. And we get that 25 equals to 9 plus x squared plus 2ax. So here we subtract 9 from this equation, equation number 2. And we get that according to equation number 2, 25 minus 9 is 16. That is equal to x squared plus 2ax. Here we subtract x squared from this equation, equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation, equation number 2 by 2x, and we get that according to equation number 2, a equals to 16 minus x squared over 2x. We found the value of a in terms of x. We only found out that inside quadrilateral, this quadrilateral BMCN, we have 4 right angles. Therefore, quadrilateral BMCN is a rectangle because it has 4 right angles. Quadrilateral BMCN is a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN. But according to our definition, BM equals to A, so we can write here that BM equals to A. And from this equation, A equals to BM equals to Cn, we derive that Cn is also equals to A. Cn is equal to A. Here we can write down that Cn equals to A. Likewise, according to the symbol that the opposite sides of a rectangle are equal to each other, we get that BC is equal to MN. BC is equal to MN. But according to our definition, BC equals to X, so I can write here that BC equals to X. And from this equation, X equals to BC equals to MN, we derive that MN is also equals to X. MN is equals to X. We write here that MN equals to X. In the next step, we will implement the Pythagoras theorem on the right big green triangle, triangle PCN. In the right big triangle, triangle PCN by PT, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PCN is PC. According to what? Okay, so therefore the square of the hypotenuse is PC squared, and it must be equal to PN squared plus CN squared. Repeat again, according to the Pythagoras theorem, in the right green triangle BCN, PC squared equals to PN squared plus CN squared. According to what is given as the question, PC equals to 6 units, therefore PC squared is 6 squared, that is 36. And it is equal to Pn squared. What is the value of Pn? It is very easy to see from the drawing that Pn equals to b plus x. Therefore Pn squared is b plus x squared. Plus Cn squared. Cn equals to a, therefore Cn squared is a squared. So in conclusion, we found out that according to equation number 3, 36 equals to b plus n squared plus a squared. Here we'll open the brackets on this side of equation number 3, and we get that according to equation number 3, 36 equals to b plus x, of course, b plus x squared equals to b squared plus x squared plus 2bx plus a squared again. Here we have in equation number 3 b squared plus a squared, therefore we substitute b squared plus a squared by 9. Okay, then we get that 36 equals to 9 plus x squared plus 2bx. So here we subtract 9 for this equation number 3, and we get that according to equation number 3, 36 minus 9 is 27, that is equal to x squared plus 2bx. Here we subtract x squared for this equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. Here we'll divide this equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. So we have the value of b in terms of x. We have already found out the value of a also in terms of x. According to equation number 1, a squared plus b squared equals to 9. We already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get the value of a squared, of course, plus b squared. We already found out that b equals to 27 minus x squared over 2x. So if you square this expression, you get the value of b squared, of course. And here a squared plus b squared equals to 9. We'll open the brackets of those two expressions, and we get that according to equation number 1, 16 minus x squared squared equals to 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And because of the fact that the denominator of those two expressions are equal, we will add the numerator of this expression to the numerator of this expression. We can do it because they have the same denominator. We do it now and we get that 27 minus x squared is equal to 27x, that is 729, plus x squared squared is x to the power of 4, minus 2 times 27 is minus 54 times x squared, all divided by 2x squared is 4x squared, and it is equal to 9. So here we have 256 plus 729 is 985, and we have x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and we have minus 32x squared minus 54x squared is minus 86x squared, is equal over 4x squared is equal to 9. So here we multiply this equation number 1 by 4x squared, and we get that according to equation number 1, 2 times x to the power of 4 minus 86x squared plus 985. Here 9 times 4x squared is 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, 2 times x to the power of 4. We have minus 86x squared minus 36x squared is minus 122x squared plus 985 is equal to 0. We will define z as x squared. If z is equal to x squared, it means that z squared is equal to x to the power of 4. So this expression in total 2x to the power of 4 will be equal in total to 2 times z squared. So we substitute 2 times x to the power of 4 by 2 times z squared minus 122 x squared is z, so we substitute x squared by z. We get that this expression in total equals to minus 122z plus 985 equals to 0. So here we got the quadratic equation, the 2z squared minus 122z plus 985 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, for this general quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now, specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and finally the coefficient c equals to 985. And the variable that we are looking for is z, so z equals to x. So we'll put the data inside the formula for x, and we find out the value or the values of z because x equals to z. And we'll get that z equals to minus b. B equals to minus 122, therefore minus b will be equal to minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884. Minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, therefore minus 8 times 985 is minus 7,880 over 2a. A is 2, so 2a is 2 times 2, that is 4. So, in conclusion, we found out that z equals to 122 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only 7,004 over 4. So here we found out that Z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4. So here we have two solutions that are possible for Z. The first solution for Z is that Z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 equals to 205.6899, and if we divide it by 4, we get that Z equals to 51.4224. So I actually found out that Z equals to 51.4224. Actually, according to our definition, Z equals to x squared, and we just right now found out that Z equals to 51.4224. So here we take out of this equation in order to find out the value of x. And the square root of 51.4224 is equal to 7.17 units. So we found out that x equals to 7.17 units. Here AB that is equal to x equals to, according to the first solution for Z, it is equal to 7.17 units. And it is actually impossible that x equals to 7.17 units, and I will explain you why. Because if you focus on the right triangle APM, on this right triangle, the hypotenuse AP equals to 5 units. And we know that the hypotenuse is the biggest side in any right triangle. Therefore, the hypotenuse AP is the biggest side in the right triangle APM. That is to say, the hypotenuse AP is bigger than AM. If the hypotenuse AP is bigger than AM, let alone that the hypotenuse AP will be bigger than AB. So if AP, so we found out that the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. So I write it down. I found out that in the right triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. Okay? So from this inequality, 5 equals to AP is bigger than AB that is equal to x, we will derive that x is less than 5 units. Okay? X is less than 5 units. But we just right now found out that x equals to 7.17 units, that is bigger than 5 units. So we have a contradiction. From one side, x must be less than 5 units, and we found out that x is bigger than 5 units. So due to the contradiction, we cancel this possibility. That is to say, z cannot be equal to 51.4224. This solution is the correct solution. And we focus on the second solution for z. The second solution for z is that z equals to 122 minus 83.6899 over 4. That is to say, z equals to 122 minus 83.6899 equals to 38.3101 over 4. So if we divide it by 4, 38.3101 over 4 is equal to 9.5775. Here we found out that z equals to 9.5775, and actually, according to our definition, z equals to x squared, and we found out that z equals to 9.5775. So we take a root out of this equation in order to find out the value of x. The square root of 9.55, the square root of 9.5775, that is x, it is equal to 3.09 units. So here we found out that x equals to 3.09 units. That is to say, x is less than 5 units. It means that this is a correct answer because we don't have any contradiction here. Here, side AB is smaller than the hypotenuse AP, that is equal to 5 units. So, what is x squared? X squared is exactly the area that we are looking for. X squared is the area of square ABCD. So we can write down that the area of square ABCD that is equal to x squared, that is equal to z, it is equal to 9.5775 square units. And that is the answer to the question, that the area of square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle, triangle ABC, angle ABC equals to 90 degrees. Inside the right triangle, triangle ABC, we have a circle, and inside the circle we have triangle DOE, and we are looking for the size of this angle, angle theta, that is in triangle DOE. It is given us the question that line segment AD equals to line segment AC, and here DE is twice as long as AD, and DE is twice as long as AC also. That is to say, AD equals to EC equals to DE over 2. So first of all, we define the length of line segment DE is 2A. Here, DE is equal to 2A according to our definition. So according to what is given as the question, we know that AD is equal to EC, and it is equal to DE over 2. But according to our definition, DE equals to 2A, so we substitute DE by 2A, and 2A over 2 is A. So from this normal equation, we will derive that AD equals to EC equals to A. That is to say, AD equals to A, and EC is also equals to A. Okay. The next step, I will present to you rule number 4, and we will implement rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisects the chord. The center of this circle is at point O. We have the perpendicular OM, and according to rule number 4, this rule, the perpendicular OM bisects chord CD. That is to say, CM equals to MD. CM equals to MD, and also CM is half of CD. CM equals to CD over 2. That MD, it is also equals to CD over 2, because chord CD has been bisected into 2 halves by perpendicular OM. We can implement rule number 4 in our drawing. Why? Because in our drawing, from the center of the circle, that is to say, from point O, we draw perpendicular on chord DE. Okay, this angle equals to 90 degrees, and this angle, it is also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord DE as T. So here, according to rule number 4, DT equals to TE. According to rule number 4, dt equals to TE, and each part TE equals to DE over 2, and dt is also equals to DE over 2. And according to our definition, DE equals to 2A, so we substitute DE by 2A. 2A over 2 is A. From this long equation, dt equals to TE equals to D over 2 equals to 2A over A equals to A, we will derive that dt equals to TE, that is equal to A. That is to say, dt equals to A and TE is also equals to A. In the next step, we define the point. We define the point of tangency of tangent AB with this circle SM. We define the point of tendency of tangent BC with this circle as N. We'll join points O and M together by straight line. So here, point O is the center of the circle. Point M is the point of the circle itself, therefore OM is the radius of the circle, so we'll define the radius of this circle as R, therefore OM equals to R. And we have here the radius OM that is drawn to the point of tendency, therefore according to rule number 1, a tangent to a circle is drawn is equal to a tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. And again, we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So inside quadrilateral BOMOBN we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So inside quadrilateral MOBN we have 4 right angles, therefore quadrilateral MOBN is a rectangle. I write it down. Quadrilateral MOBN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other, that is to say MO equals to BN. MO equals to BN. But we have already found out that MO equals to R, so I can write here that MO equals to R. And from this equation, R equals to MO equals to BN, we derive that BN is also equals to R. Here, BN is equal to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. ON equals to MB. but we have already found out that ON equals to R. So we can write here that ON equals to R. And for this equation, R equals to ON equals to MB. We derive that MB is also equal to R. MB equals to R. And I feel that MB equals to R. So we actually found out that for the other MOBN is not a rectangle but a square because all of its sides are equal to each other, they are equal to R. So we can write down that for the other one MOBN is a square. In the next step, I'll present to you rule number 10 and we'll implement rule number 10 in our drawing. So here we have the external point P. From the external point P we have tangent PA for this circle, and from the external point P we have the straight line that intersects in the circle at points B and C. So if this is the data that has been given to us, then the following equation is true, that PA squared equals to PB times PC. Again, PA squared equals to PB times PC. Okay, we can implement rule number 10 in our drawing. If we focus on the external point C, here the external point C, we have tangent CN to this circle, and from point C we have the straight line that intersects with this circle at points E and D. Therefore, we can implement here rule number 10 according to rule number 10. We'll get that Cn squared equals to Ce times Cd. Again, Cn squared equals to Ce times Cd. Repeat again. If we focus on the external point C, according to rule number 10, we get that Cn squared equals to Ce times Cd. So Cn squared equals to Ce. Ce equals to A, therefore we substitute Ce by A times Cd. What is the value of Cd? It's very easy to see from our drawing that Cd equals to A plus A plus A, that is 3A. So we substitute Cd by 3A. So in conclusion, we found out that according to number 10, Cn squared equals to A times 3A, that is to say Cn squared equals to A times 3A is 3A squared. So here we take a root out of this equation and we get that Cn equals to the square root of 3A squared. The square root of 3A squared is the square root of A squared is A times square root of 3 is square root of 3. So in conclusion, we found out that the square root of 3A squared equals to the square root of 3 times A. So we can write here that Cn equals to the square root of 3 times A. Likewise, focus on the external point A. For the external point A, we have tangent AM to this circle, and we have the straight line from point A that intersects with this circle at points D and E. Therefore, we can implement here rule number 10. So, according to rule number 10, AM squared equals to AD times AE. Again, AM squared equals to AD times AE. Repeat again, according to rule number 10, AM squared equals to AD times AE. So AM squared equals to AD. AD equals to A, so substitute AD by A times AE. AE equals to A plus A plus A, that is 3A, so we substitute AE by 3A. So in conclusion, we found out that according to rule number 10, AM squared equals to A times 3A is 3A squared. AM squared equals to 3A squared. We take out of this equation and we get that AM equals to the square root of 3 times A. So AM is also equals to the square root of 3 times A. So we can write here that AM equals to the square root of 3 times A. So in the next step, I'll copy the right triangle ABC in a new page and we'll analyze triangle ABC. What is the length of side AB? From the drawing it is very easy to see that the length of side AB is equal to 3 times A plus R. Again, the length of side AB is equal to 3 times A plus R. And what is the length of side BC? The length of side BC is also square root of 3 times A plus R. And what is the length of the hypotenuse AC? The length of the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So actually, this is the right triangle, triangle ABC. That I copied from the original drawing. Side AB and side BC, those two sides, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. So AB equals to AC, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if we define one angle as alpha, then the other angle must be also equal to alpha because of the fact that they are equal to each other. This angle equals to 90 degrees, therefore the other two angles must be also equal to 90 degrees because 90 degrees plus 90 degrees is 180 degrees, that is the sum of the angles in any triangle. So found out that alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divide this equation by 2, and we get that alpha equals to 90 degrees over 2 is 45 degrees. So here, angle alpha equals to 45 degrees. So we actually found out that triangle ABC is not only a right triangle, but also an isosceles triangle. So we continue to focus on the right triangle, triangle ABC. We focus on this angle. It is very easy to see that cosine 45 degrees of this angle is equal to BC over AC again. Cosine 45 degrees of this angle equals to BC over AC. So cosine 45 degrees equals to BC. We've already found out that BC equals to the square root of 3 times A plus R over AC. We've already found out that AC equals to 4A. Cosine 45 degrees is equal to 1 over square root of 2. So in conclusion, we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. Here we multiply this equation by 4A, and we get that 4A over square root of 2 equals to square root of 3 times A plus R. Here we'll substitute 4 by 2 times 2, and we get that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substitute one of the 2's by square root of 2 times square root of 2, and we'll get that square root of 2 times square root of 2 times 2A over square root of 2 equals to square root of 3 times a plus r. So here we have square root of 2 in the numerator, and we have square root of 2 in the denominator, so square root of 2 will get cancelled, and we're left only with square root of 2 times 2a, that is equal to square root of 2 square root of 3 times a plus r. Here we subtract square root of 3 times a from this equation, and we get that 2 times square root of 2 times a on square root of 3 times a equals to r. Okay, so here we take a as a common factor of those two expressions. So what is left from 2 times square root of 2 times a after we took from it a as a common factor? What is left is actually 2 times square root of 2. And what is left from minus square root of 3 times a after we took from it a as a common factor? What is left is actually minus square root of 3. That is equal to r. So in conclusion, we found out that the radius of the circle r equals to a times 2 times square root of 2 minus square root of 3. Okay. You know that point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. So in the next step, I will copy the right green triangle DTO in a new page, and we will analyze triangle DTO. So this is the right triangle DTO that I copied from the original drawing. It is very easy to see from the drawing that cosine theta equals to dt over dO. Again, cosine theta equals to dt over dO. dt equals to a, dO equals to r. So cosine theta equals to a over r. And we already found out that r equals to a times 2 times square root of 2 minus square root of 3. So we substitute r by a over 2 times square root of 2 minus square root of 3. So here we have a in the numerator and a in the denominator, so a will get cancelled. And we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Okay. Our mission is to find out the value of theta itself. So in order to find out the value of theta itself, we'll operate the opposite function of cosine, that is cosine minus 1 on the result. This is 1 over 2 times square root of 2 minus square root of 3. This way we get the value of theta itself. So we'll operate the opposite function of cosine, that is cosine minus 1 on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way we get the value of theta itself. Okay, so if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, we get that this expression equals to 24.203 degrees. And it is equal to theta. So we found out that the size of angle theta is 24.203 degrees. Here, the size of this angle theta is equal to 24.203 degrees. We finished with the second question. In the next step, I'll summarize the lecture. I'll start with the first question, of course. In the drawing we have square ABCD, line segment AP equals to 5 units, line segment BP equals to 4 units, line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all we did the construction. We extended the side DC of the square by a straight line, and from point P we drew perpendicular on the extended DC. So this angle equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point P and the extended DC as N. Then we did a second construction from point B. We drew perpendicular on PN. Again, from point B, we drew perpendicular on PN. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point B and PN as M. Then we defined side PM as B, we defined side PM as A, and we implemented the Pythagoras theorem on the right green triangle PBM. According to the Pythagoras theorem in the right green triangle PBM, PB square equals to PM square plus BM square. And again in the right triangle PBM, PB square equals to PM square plus BM square. So here PB equals to 3 units, therefore PB square is 3 squared, that is 9. And it is equal to PM square. PM is B, so PM square will be equal to B square plus PM square. BM is 8, therefore PM square is A square. So in conclusion, we found out that according to equation number 1, 9 equals to B square plus A square. Here DC, if a side of square ABCD, it is absolutely a straight line. Then we extended the straight line DC by a straight line. In this way, we got line segment DN. When you extend the straight line by a straight line, the result must be a straight line, therefore DN is a straight line. So if you focus on the straight line DN at points, on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DN at point C? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be equal to 90 degrees. So in quadrilateral BMCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be equal to 90 degrees. In order to complete the sum of the angles in quadrilateral BCNM to 360 degrees, this angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, quadrilateral BMCN has 4 right angles. Okay, so then we focused on the lower side of line segment AM at point B. Point B, we have 2 right angles. The sum of 2 right angles is 180 degrees. Therefore, angle ABM is equal to 180 degrees. Therefore, angle ABM is a straight line. If angle ABM is a straight line, then line segment ABM is a straight line, and if line segment ABM is a straight line, then line segment AM is also a straight line. So if line segment AM is a straight line, then this shape APM, is a right triangle. So we can implement the Pythagoras theorem on the right green triangle, triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus AM square. Repeat again, AP square equals to PM square plus AM square. AP equals to 5 units according to what is given as the question. Therefore, AP square is 5 square, that is 25. And is equal to PM square. PM is B, so PM square is B square plus AM square. AM equals to X plus A. Therefore, AM square is X plus A square. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus A plus A square. So we open the brackets on this side of equation number 2 and found out that according to equation number 2, 25 equals to B square plus A plus X square. A plus X square equals to A square plus X square plus 2AX. So here in equation number 2, we have B square plus A square. But according to equation number 1, we have only found out that B square plus A square is equal to 9. Therefore, we can substitute B square plus A square in this equation, equation number 2, by 9. We did it when we got that 25 equals to 9 plus X square plus 2AX. We subtracted 9 from this equation, equation number 2, and found out that 35 plus 9 is 16, that is equal to X square plus 2AX. We subtracted X square from this equation, equation number 2, and found out that 16 times X square equals to 2AX. Here we divided this equation, equation number 2 by 2x, and found out finally that A equals to 16 times X square over 2x. So we have the value of A in terms of X. We already found out that quadrilateral BMCN has 4 right angles, therefore quadrilateral BMCN is a rectangle. We know that the opposite sides of a rectangle are equal to each other, that is to say BM equals to CN. But according to our definition, BM equals to A. And so from this equation, A equals to BM equals to CN, we derive that CN is also equals to A. Here CN equals to A. Likewise, according to the theorem that the opposite sides of a rectangle are equal to each other, we get that BC equals to MN. BC equals to MN, but we know that BC equals to X. So for this equation, X equals to BC equals to Mn, we derive that Mn is also equals to X. Here Mn equals to X. In the next step, we implemented the Pythagoras theorem in the right green big triangle, triangle PCN. According to the Pythagoras theorem, in the right green triangle, triangle PCN, PC square equals to PN square plus CN square. Repeat again. In the right green triangle, triangle PCN, PC square equals to PN square plus CN square. PC equals to 6, therefore PC square is 6 squared, that is 36. Pn equals to b plus x, therefore Pn squared is b plus x squared. Plus Cn squared. Cn equals to 8, therefore Cn squared is a squared. So in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to b square plus x, b plus x square equals to b square plus x square plus 2bx plus ax plus a square. Here we have b square plus a square, so we substitute b square plus a square by 9 and we got that 36 equals to 9 plus x square plus 2bx. Here we subtracted 9 from this equation, equation number 3, and found out that 27 equals to 36 plus 9 is 27, therefore 27 equals to x squared plus 2bx. Here we subtracted x squared from this equation, equation number 3, and found out that 27 minus x squared equals to 2bx. Here we divided this equation, equation number 3 by 2x, and found out that finally b equals to 27 minus x squared over 2x. So we have the values of a and b in terms of x. Then, according to equation number 1, we have only found out that a squared plus b squared equals to 9. We have only found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get the value of a squared, of course, plus b squared. We have only found out that b equals to 27 minus x squared over 2x. So if we square this expression, we get the value of b squared, of course. So here a squared plus b squared equals to 9. We open the brackets of those two expressions and found out that 16 minus x squared equals to 16 squared is 16 minus x squared squared equals to 16 squared, that is 256, plus x squared squared is x to the power of 4 minus 2 times 16 minus 32 x squared. And because of the fact that those two expressions have the same denominator, therefore we can add the numerator of this expression to the numerator of this expression because they have the same denominator. We did it and we got that 27 minus x squared squared equals to 27 squared, that is 729, plus x squared squared is x to the power of 4 minus 2 times 27 is minus 54 times x squared. All divided by 2x squared, that is 4x squared, that is equal to 9. Here 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. Minus 32x squared minus 54x squared is minus 86x squared over 4x squared equals to 9. Here we multiply this equation, equation number 1 by 4x squared, and found out that according to equation number 1, 2 times x to the power of 4 minus 86x squared plus 985 equals to 36x squared. Why? Because 4x squared times 9 is 36x squared. Here we subtracted 36x squared from this equation, equation number 1, and found out that according to equation number 1, 2 times x to the power of 4 equals to minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Here we define z as x squared. If z equals to x squared, it means that the z squared will be equal to x to the power of 4. Therefore, 2 times x to the power of 4 will be equal to 2z squared. So we substitute 2 times x to the power of 4 by 2z squared minus 122, z is x squared, so we substitute x squared by z. So we have here minus 122z plus 985 equals to 0. So we have here quadratic equation 2z squared plus 122 plus 985 equals to 0, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z, so add z x equals to z. So we put the data inside the formula for x and found out the value of z because x equals to z. So z equals to minus b, b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared, b is equal to minus 122, therefore b squared is minus 122 squared, that is 14,884 minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is 7,880, all divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So in conclusion, we found out that z equals to 122 plus minus 14,884 minus 7,880 is equal to 7,004. So inside the root we left only with 7,004 divided by 4. So z equals to 122 plus minus the square root of 7,004 is 83.6899, all divided by 4. So here we have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we will get that z equals to 51.4224. So we found out that z that's equal to x squared according to our definition, it is equal to 51.4224. So if we take a root out of this equation, we get the value of x. Okay? So we took a root out of this equation and found out that x equals to the square root of 51.4224, that is 7.17 units. So here we found out that AB that is equal to x, it is equal to 7.17 units, but it is impossible that x equals to 7.17 units. Why? Because in the right triangle, triangle APM, the hypotenuse AP equals to 5 units. And the hypotenuse AP is the biggest side in any right triangle. Therefore, the hypotenuse AP is the biggest side in this triangle, triangle APM. That is to say, AP is bigger than AM. So if AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. So we found out that the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. I repeat again, here in the right green triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. So from this inequality, we get that x is less than 5 units. But we just right now found out that x equals to 7.17 units, that is bigger than 5 units. So here we found out that x must be less than 5 units, but according to the answer for z, x is bigger than 5 units. So due to the contradiction, we cancel the possibility that z equals to 51.4224 units, and We focused on the second solution for Z, and the second solution for Z, it is actually Z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 33.3101, and if we divide it by 4, we get that Z equals to 9.5775. So Z, that is equal to x squared according to our definition, is equal to 9.5775, and if we take out of this equation, we get the value of x, of course, and found out that x equals to 3.09 units. Here, x equals to 3.09 units, and it is less than the product AP that is equal to 5 units. Therefore, there is no contradictions here. Therefore, the product is bigger than x. Okay, so therefore, and what is the area of square ABCD? The area of square ABCD is x squared, and you just like now found out that x squared that is equal to Z, it is equal to 9.5775 units. That is to say, the area of square ABCD equals to 9.5775 square units. Okay, we finished with the first question, then I presented to you the second question. So in the drawing, we have the right triangle ABC. Angle ABC equals to 90 degrees. Inside the right triangle, we have a circle. Inside the circle, we have triangle DOE. And we are looking for this angle theta. It is given us the question that AD equals to EC, and DE is twice as long as AD. DE is also twice as long as EC. That is to say, AD equals to EC equals to DE over 2. So we define DE as 2A, DE equals to 2A according to our definition, and according to what is given us in the question, we know that AD equals to EC equals to DE over 2. But DE equals to 2A, so we substitute DE by 2A. 2A over 2 is A. So in conclusion, we found out that AD equals to EC equals to A. AD equals to A and EC equals to A also. Then I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. So, point O is the center of the circle, we have perpendicular OM to chord CD, and according to rule number 4, the perpendicular OM bisect chord CD. That is to say, CM equals to MD, and also CM is half of CD, and MD is also half of CD. Can implement rule number 4 in our drawing. From point O, we go perpendicular to DE. Okay. So, according to rule number 4, DT equals to TE. DT equals to TE, and each part is half of DE. That is to say, DT is equal to D over 2, and TE is also equals to DE over 2. That is to say, DT equals to TE equals to DE over 2, but according to our definition, D equals to 2A, so we substitute DE by 2A, and here 2A over 2 is A. So from this long equation, we found out that DT equals to TE equals to A. That is to say, DT is equal to A, and TE is also equals to A. Then we define the point of tendency of tangent AB with this circle SM. We define the point of tendency of tangent BC with this circle SM. We join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that it is equal to R according to our definition. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of the circle that is equal to R. We have the radius ON that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So in quadrilateral OMBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So quadrilateral OMBN, that has 4 right angles, is a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, OM equals to NB. But according to what we have already found out, OM equals to R. So for this equation, R equals to OM equals to Bn, we will derive that Bn is also equals to R. Here Bn equals to R. Likewise, according to the sum rule that MB equals to ON, according to the sum rule that the opposite sides of a rectangle are equal to each other, we get that MB equals to ON. But we already found out that ON equals to R. So for this equation, R equals to ON equals to Bn, we derive that MB is also equals to R. So we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to R. Then I presented to you rule number 10 and we implemented rule number 10 in our drawing. According to rule number 10, if we have the external point 3, from the external point 3 we have tangent PA, and we have the straight line from point P that intersects with this circle at points B and C. So if this is the data that has been given to us, then PA square equals to PB times PC. Again, PA square equals to PB times PC. Implemented rule number 10 in our drawing. In our drawing, if we focus on the external point C, we have tangent CN, and we have the straight line that intersects with this circle at points C and D. Therefore, according to rule number 10, Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. The external point C, according to rule number 10, Cn square equals to Ce times Cd. So Cn square equals to Ce is A, so we substitute Cd by A, Ce by A. Cd equals to A plus A plus A, that is 3A, so we substitute Ce by 3A. So in conclusion, we found out that Cn square equals to A plus 3A, so Cn square equals to A plus 3A times 3A. So Cn square equals to A times 3A, A times 3A is 3A square. So we found out that Cn square equals to 3A square. We took out of this equation and found out that Cn equals to the square root of 3 times A. So here Cn equals to the square root of 3 times A. Likewise, we focused on the external point A. From the external point A, we have tangent AM, and we have the straight line that intersects with the circle at points D and E. Therefore, according to rule number 10, we get that AM square equals to AD times AE. Again, AM square equals to AD times AE. I repeat again, according to rule number 10, in the external point A, AM square equals to AD times AE. So AM square equals to AD is A, so we substitute AD by A, times AE. AE equals to A plus A plus A, that is 3A, so we substitute AE by 3A. So in conclusion, we found out that AM square equals to A times 3A. AM square equals to A times 3A is 3A square. We took out of this equation and found out that AM equals to the square root of 3 times A. Here, AM equals to the square root of 3 times A. Then I copied the right triangle ABC. Here in the new page, and we analyze triangle ABC. AB equals to the square root of 3 times A plus R. BC is also equals to the square root of 3 times A plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is the right triangle ABC that I copied from the original drawing. If we, here AB equals to BC because both sides are equal to square root of 3 times A plus R. And we have the rule that in front of equal sides in the triangle there are equal length, there are equal angles. In front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha. This angle equals to 90 degrees, therefore the rest two angles must be also equal to 90 degrees, because 90 degrees plus 90 degrees is 180 degrees, that is the sum of the angles in any triangle. So here alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha. 2 alpha equals to 90 degrees. We divided this equation by 2 and found out that alpha equals to 90 degrees over 2 is 45 degrees. So those two angles are equal to 45 degrees. So if we continue to focus on the right angle ABC, here the cosine 45 degrees of this angle equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. Cosine 45 degrees equals to BC over AC. BC equals to square root of A times A plus R, and AC equals to 4A. Cosine 45 degrees equals to 1 over square root of 2. So in conclusion, we found out that 1 over square root of 2 is equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A and found out that 4A over square root of 2 equals to square root of 3 times A plus R. We substituted 4 by 2 times 2 and we found out that 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substituted one of the 2's by square root of 2 times square root of 2 and found out here that square root of 2 times square root of 2 times 2A over square root of 2 equals to square root of 3 times A plus R. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we left only with square root of 2 times 2A, that is equal to square root of 3 times A plus R. Here we subtracted square root of 3 times A from this equation and found out that 2 times square root of 2 minus square root of 3 times A equals to R. So in conclusion, we found out that the radius of the circle R equals to A 2 times square root of 2 times A minus square root of 3 times A. Here we took A as a common factor. So here A is a common factor. What is left from 2 times square root of 2 times A after we took point A as a common factor? What is left? It is actually 2 times square root of 2. And what is left from minus square root of 3 times A after we took point A as a common factor? What is left? It is actually minus square root of 3. So in conclusion, found out that the radius of the circle equals to A times 2 times square root of 2 minus square root of 3. So here, point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle. I copied the right rectangle OTD DOT in this new page and analyze triangle DOT. This is the right angle DOT that I copied from the original drawing. It is very easy to see from the drawing that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Cosine theta equals to dt over do. Dt equals to A, do equals to R. Then we already found out that R equals to A times 2 times square root of 2 minus square root of 3. Therefore we substitute R by A times 2 times square root of 2 minus square root of t minus square root of 3. Here we have A in the numerator and A in the denominator, so A will get cancelled and we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of angle theta itself, we will operate the opposite function of cosine, that is cosine minus 1 of the result, that is 1 over 2 times square root of 2 minus square root of 3, and this way we get the value of theta itself. So if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, we get that the value of this expression equals to 24.2 of 3 degrees. That is to say, we found out finally that the size of angle theta is 24.2 of 3 degrees. I repeat again, the size of this angle theta, it is equal to 24.203 degrees. Okay? Thank you very much.